Thank you. Thank you for inviting me, and thank you for being still awake. So, yeah, why do I choose such a complicated title? It's because I think, and we will see that I don't think we should name a neonate as immature or need to develop. It's just a different entity. And that's what I'm going to cover now. That is a very special period of our life, but it's not just immune deficient or undeveloped or immature. So I think immune trajectory illustrates that we come from one state to another state, and we will see how breastfeeding influences that. So that's the plan. Okay. So a lot of research done on breastfeeding is on that part of life, is how it's about the direct effect of, there is some, can we close the door? Is that possible? Yeah?
If you also look at your project.
Okay, perfect. Sorry for interruption. So you can look at the effect of breastfeeding on immune health on the early life, and then it's really the direct effect that you're looking at, how breast milk is somehow complementing the immune system of the neonate or in an early postnatal life. And you can also look at the long-term effect. And here is this notion of trajectory. How can breastfeeding influence the development of the immune system and make you healthy versus unhealthy in many, many years later? So I will start by talking about this and finish by that part. So what do we know about the immune system in early life? And I would like maybe to ask you a little quiz. Would you consider that a neonate is a small adult? Who would say that? No? Yeah, good. However, I think that most of the preventive and therapeutic approach of the neonate are exactly the same as the one for an adult. And if you look at research in immunology, I would say 90% of the research, or probably 99% of the research, is done on adult. And then we extrapolate all that to the neonate and think we are doing things correctly. So you all agree this is probably not what should be done, and more research on the neonate itself. Others have adapted and say, okay, it's not a real adult, it's an adult that has no bacteria. So you will find also much literature about germ-free mice, and people just conclude that immune system maturation just can be recapitulated by using germ-free mice that you colonize. But again, it's absolutely not true, and I won't go into those details. There are many differences that now are really shown that if you colonize an adult mice, you do not get the same as you colonize a neonatal mice, in particular regarding the IgE, but also NK cells, and many, many effects I see that are different when you colonize an adult versus a neonate. It looks like obvious, but I guess 20 years of research has been done on adult germ-free mice, and then we extrapolate. So let's not extrapolate. So let's consider the neonate as a specific period of life with specific needs and specific constraints. And then I think this way we could propose a preventive approach and therapeutic approach that are really tailored to that period of life. So I will go through briefly, of course, some specificity I think are really characteristic of early postnatal life. So of course that's very obvious. The early life is still developing, and that's why people like to talk about the neonate as developing immature. But we will see there are many other characteristics. So, okay, it's developing. An important characteristic of being developing is that the barrier are not fully developed, and in particular the skin is not perfectly developed yet, and this makes the infant very sensible to infectious disease, but also allergic disease, and also, as you all know, susceptible to gastrointestinal infection, because the first line of defense is not that optimal. Still developing, we could consider the immune system of a neonate as immunodeficient. If we forget we are mammals. And then indeed there is a maturation in terms of production of systemic and mucosal antibodies. Something else is still developing in early life is the microbiota, and we come from a quasi-sterile environment because no bacteria are described by some people in utero, to a very rich microbe-rich environment. So, and we all know how bacteria are important for the regulation of the immune system. And in fact, I think we cannot consider the immune system without the bacteria. It's a whole system that includes the bacteria. So the neonate and the early life doesn't have that established, and of course it influences the immune system function. And then let's go to other thing. Okay, this is a growth curve. It's obvious. In early life, we are growing. We are changing every day, while in adult, we are somehow in a stable phase. So you compare an adult that is stable compared to a neonate that is every day changing, and in particular, the organs are getting developed. And development and growth is associated with a type of immunity that is the same immunity that is involved in allergic reaction. So there are beautiful papers, for instance, from Bart Lambrecht, published in 2016, showing that when the alveoli of the lung are developing, you have IL-33 that is produced. And this cytokine is essential to induce ILC2 activation and T helper 2 immunity, the one involved in allergic disease. So it just, let's say by coincidence, when you're developing, at the same time, you have a propensity to have Th2 immune response because this is what you have for repair, for development. Are you okay? Yeah? Question? Please interrupt me while I'm talking. It may be more dynamic. And another observation, maybe that's more speculation, but when your organ or the organ of a neonate are developing, you don't want to have a strong inflammatory response, because if you have that kind of immune response, you can also have scars, and this is certainly what you don't want to have for developing tissue. So a very strong immune response should be avoided. So these are some constraints that you specifically find in early life development that is associated with low inflammatory immune response. And then, come on, let's see this poor baby coming on Earth and discovering such an amount of new antigen. This never happens once we are adults. So the immune system of the neonate, together with the mother, has to cope with tremendous amount of exogenous antigen. Of course, the microbial one, but also the food one, and we will talk a lot about antigen in breast milk, and then, of course, in solid food, and you have this exposure of the immune system to dietary antigen, which are very important as well for driving the immune trajectory, as I like to say. So, and then about the distinct reactivity, a neonate immune system is not only immune deficient, it's just reacting differently. Differently because all is new, so you don't have memory immune response, meaning that immune response are slow and not intense. So you cannot expect having the same reactivity in that period of life. But that distinct reactivity is also illustrated here, and this is, I think, a super important paper coming with two other papers in the same issue of Nature in '96. If you inject a mice with the virus with the dose that you would inject in an adult mice to have cytotoxic immune response, so 1,000 virus dose in an adult mice, you have huge cytotoxicity induced. You do that in a neonate, well, nothing happened. So if you only look at this, you say, okay, the immune system of a neonate is just immune deficient, doesn't work. Well, then you would say, I will increase the dose. That's what we do with vaccine. It doesn't work. So let's increase the dose. It will not work neither. What worked was decreasing the dose. And you can see in this beautiful paper that you decrease the dose by 1,000. You start having very potent immune response. So what does it mean? It means that a neonate is not good at coping with high amount of antigen. It can work very well as long as you have very low dose. That's one thing. So if you want to vaccinate, maybe better to adapt the protocol to very low dose. Well, currently it's not what is done, and I still don't understand why. But you will see that Breastmilk know that. So to summarize, in early life, the immune system has some constraints, some needs, and some specificities that we're starting to discover. And I think this is very important to have a good preventive and therapeutic approach. So weak barrier, few immune cells, microbiota getting established. This is all the characteristic of immature, let's say, but also constraint like the growth, and this is associated with type 2 immunity, bias towards allergy, lots of challenges, new antigen from microbiota and diet, and then specific immune reactivity, no memory or few memory, and respond to low level of antigen. And then early life is associated also with specific help. Also, I'd like to talk about one day maybe about aging, because it's very interesting. Aging and immune system in aging is also so different from the adult. And again, we use the same approach as the adult. The difference, I think, is that aging doesn't have that help, and that's a pity. So we may inspire from the help that a neonate receives maybe one day to provide help also for aging immune system. So an early life-specific help is breast milk. There is something also is interesting is vernix caseosa. I'm not going to talk about that, but I think it's very interesting, this thing that cover the baby, full of growth factor, full of antimicrobial molecule. I think we may inspire from that when we look at breast milk. But today is about breast milk. So breast milk. Okay, so this is a total artificial graph where we forgot the mammal nature, our mammal nature. And that there is an in utero period of life where there is, as we just heard, transfer of antibodies and essentially IgG during the last trimester. And comes the breast milk that is a perfusion of IgA. I was just heard by Jire and others this morning and early this afternoon, that will just cover the mucosa, maybe also go in the first day into the serum, and together with this, you also get antimicrobial factors. So that's not only that. So I think that was covered, but this is this is a scheme, maybe something hypothetic, maybe it's not only from the gut, but probably what's happening is the mother exposed to microbe in the gut, in the lung, will stimulate a B cell differentiation into plasmacyte that will go in the breast milk and secrete immunoglobulin that are specific to microbe found in the environment. And that's probably important also for milk bank. I think it's good to get milk from your region and not from another region. And now the milk bank with mondialization, and you would get milk from India. Well, I don't think the antibodies from breast milk in India are appropriate for a child growing in Switzerland and vice versa. So we should not forget how breast milk is adapted to the environment and how dynamic it is. How are you? Good. Okay. Any question? Okay. All right. Okay, then I move on. Okay, so breast milk, potent, dynamic, varied antimicrobial activity. It's not like an antibiotic that will just kill a few bacteria. It's much more than that. It will neutralize, prevent entry of pathogen. Of course, we heard a lot from Pereira about the present immune cells that are also adapting, and you get a huge amount of immune cell in the breast milk when the mother is infected. You have lots of molecules endowed with antimicrobial activity, such as lysozyme. I recently read that it was discovered by Jules Bordet, a Nobel Prize, more than 100 years ago. He did not give that name, but he found that bacteriolytic molecule already 100 years ago. And in addition, we have the capacity to promote the growth of good bacteria. So you have the prebiotic, the probiotic also. I didn't talk about that. So you have the antimicrobial, the prebiotic here. And yeah, so you have, we will hear a lot about the growth of, let's say, good bacteria. You have microbiota in the breast milk and antimicrobial molecules. So this is a really complex way to approach prevention of infectious disease. Is not only antimicrobial, it's antimicrobial plus prebiotic plus probiotic, and in addition, growth factors. So breast milk is also providing help for development of the barrier, certainly in the oral respiratory, the upper respiratory mucosa, but also in the gut. And this is an observation made a long time ago, showing that if you incubate epithelial cells with colostrum or with more mature milk, you induce proliferation of those epithelial cells, and many growth factors are involved in that, in particular EGF, but many others. So you have a molecule to repair, to stimulate the barrier, antimicrobial, probiotic, prebiotic. I think we cannot design a best treatment to prevent infection. So this is I was telling, the very first period of life, early life. Breastfeeding is complementing the immune system of the neonate, and we should look at the neonate immune system as this complex mother component plus neonate component. And then I think it's something complete, certainly not immune deficient. Yeah, it's all written, so I will not go through, but you see how it's complementary. Okay, so that is clear, extremely clear. Breast milk is specifically adapted to the needs and requirement of the early life, and this is all this dynamism and the pleiotropy and diversity of molecules that you find in breast milk that certainly account for the capacity of breastfeeding to be the best way to prevent infectious disease, and as again shown in this recent meta-analysis. Okay, still no question? Okay, so now let's go to this other part. Would breastfeeding influence the immune trajectory? And we now know that immune system is not only important for infectious disease prevention. We know that immune system is, of course, involved in disease related to lack of tolerance, such as allergic disease, but we know also that immune system is involved in metabolic related disease like obesity, diabetes, cardiovascular disease. So can we speculate and analyze and study whether breastfeeding will have a long-term influence on these trajectories? How could this happen? I think the most obvious way, and what many people are looking at now, is about the effect of breastfeeding on microbiota. So if breastfeeding has that many molecules that influence the microbes, it will influence also the microbiota, and we all know now how microbiota is important for health. So if breastfeeding will shape the microbiota in early life, we expect it will influence the long-term risks for disease. But what is the ideal microbiota? That's the question. And of course, the ideal microbiota here is certainly not the same as in another continent. So that's we probably won't be able to generalize any finding, but at least the concept. So that's certainly a good thing to look at. The main research we have been doing is about the presence of antigen in breast milk, which is certainly a major driver of immune system, I would say, education. So here you have data that we collect from France and Australia, and you have the level of ovalbumin, an egg antigen in breast milk. You see it's about, we have about 50% of sample that we collected where we can detect egg antigen, and the level in those positive samples is around 100 picogram per ml. As you probably know, beta-lactoglobulin in cow milk is in the range of milligram per ml. So we are clearly not in the same range of antigen amounts. And then that's a research we have been doing for now 5 years at least. We have been looking at whether you find respiratory allergen in breast milk. And in fact, we find it. And each time you find something, in fact, it's obvious because you all know that most of the things that you inhale don't go to the lung. In fact, you ingest because there is this mucociliary epithelium, and that is bringing things back to the oral cavity. And once a particle is too big, like more than 5 micrometer, it will end up anyway in the digestive tract. So what you inhale, probably 95%, that was shown in the 80s with the radioactive molecule, end up in the gut. So it's normal that you have, in fact, respiratory allergen. Here we look at DERP1 in breast milk. And again, it's exactly the same kind of range, around 100 picogram of ml of DERP1 you find in breast milk. And very similar to in Brazil, France, and Australia, which have very different climate, way of living, we find the same. And then more recently, we have been looking also at microbial antigen, not the microbe itself, the antigen. And I will tell you later on why we look at that. And we look at malaria antigen with Thomas Egwang in Uganda. And we find that you can have malaria antigen in the milk of an infected mother. So you see about 10% of mother will have some malaria antigen in the breast milk. But you know that you can only get the disease because of transmission of the parasites through a mosquito. So this will certainly not infect the baby. But as you will see, we wonder what does it do on the immune system. Question? No? Do you want to ask you a question? No?
Might be better to go ahead and we'll have
yeah, but it's to see if they are still awake. So... Okay, so what's next? What's next? The next is what's happening. Okay, it's good to look at composition, but I think it's important to look at composition and health outcome. There are so many studies now coming out about composition, but then what do you do with all that? I think it's, if possible, it's good to link this with outcomes. But then you need lots of money to have those studies, of course. So then, okay, let's look at this, and let's look at this in mice, which help you to eliminate the famous confounding factor, do causal relation and mechanism, and then maybe one day translate to the human. So a long time ago, now it's 11 years ago, and I started that much earlier in 2004, I did wonder whether you can induce oral turns through breast milk. And I developed a mouse model in the lab of Nicolas Gleichenau's and did that in collaboration also with Valerie Julia. We check if when you expose a lactating mother to egg antigen, would this lead to prevention of asthma? We use egg antigen as a model for asthma, and egg was given intranasally or by aerosol. We check, we find in the milk in very low amount as well, maximum nanogram per ml. And then we check in the adulthood of those mice if they were susceptible to allergic response to OVA, and they were protected. And then it took a lot of time to translate that to the human. So here are the results that obtained analyzing data and doing some measurement in a birth cohort from Susan Prescott in Perth. So what we did is that we took milk at 3 months and 6 months and measured the level of albumin in those breast milk. And we look at the outcome egg allergy in the children at 1 year and 2.5 years. So you see this concept of trajectory. So we measure the content in OVA in breast milk 3 and 6 months, and then we look at the child at 1 and 2.5 years. Here are infants that were exposed to breast milk with no OVA. Here is breast milk containing OVA, both either at 3 or at 6 or at both time points. You see at 1 year a trend, but nothing significant. And at 2.5 years, you see that you have now a significant protection from egg allergy in children who had been exposed to egg through breast milk. Of course, the number are not sufficient. You don't see the number here, but it's not a lot. We have in total 100 infants. It's not enough, of course. It's an observational study. It's not intervention, so there are lots of limitation, but I think it's the first proof that there is hope that you could prevent egg allergy through breastfeeding as long as you have egg allergen in the milk. Unfortunately, not all the mothers that are eating an egg have egg in the milk. Surprisingly, a quarter of mothers will never have any detectable egg in their milk, even though they are eating 5 eggs a week. And so that's why we need to know how this gets into there and how to increase the chance to have it. So that was showing that egg is good, but it's not enough. In the mice, we could modulate the breast milk composition and have milk containing egg, but no TGF-beta. And this is what you see here. This is what I just showed you. Egg in breast milk versus no egg in breast milk, and we know that the milk contained TGF-beta in the mice also. Now, if we neutralize TGF-beta and there was no TGF-beta anymore in the breast milk of the mother, that's in the mother, that's important, you see that even though you have egg antigen in the milk, you don't have any protection. So you see that, again, that complementarity, not only for the very beginning of life, but also for the education and the long-term outcome. You need to have the antigen, but some cofactor that the neonate is missing, and then the mother is providing that or not, and will help in dictating immune tolerance. So you see here, for instance, already different long-term outcome just by modifying a few factors. You have no egg, you have no TGF-beta, you see that the long-term outcome is absolutely not the same just by modulating egg and TGF-beta. So we can understand why there is so much difference in terms of protection from allergy. And then what we also find, it was that protection was associated with T helper 1 cell development, and you mentioned how important is development of T helper 1 immunity. We think that microbiota is involved in that maturation towards Th1. Certainly other factors in breast milk contribute to the development of T helper 1. Okay, so egg is good, it's not sufficient. You need cofactor, and TGF-beta is one of those cofactors that we show in the mice need to be proven in the human. And then we did a lot of research of antibodies, in particular IgA and IgG, and we wonder if a mother has been exposed to the egg, which is the normal situation. In the real life, there are very few mothers that are naive to eggs, so they all have antibodies, IgA and IgG to OVA. Does it change something? Yeah, it changes a lot. So what does it change? It changes that if you have in the breast milk the antigen and IgG, then you have the formation of immune complex. And these immune complex are transferred to the neonatal Fc receptor. They will be captured by antigen-presenting cells, and this time not induced Th1 cells, but FOXP3 Tregs. And now the protection will be extremely strong, very long life, and we have a protection not associated with Th1, but with FOXP3 Treg. And the Mishoko was supposed also to come here, and she also recently had the same observation as we did, plus additional experiment showing the role of FcRn on antigen-presenting cell. So I guess you will ask me about IgA. We checked the role of IgA in the mice. We inhibited the presence of IgA in the milk by giving an antibody that prevents the migration of B cell to the mammary gland. And then we checked, we had no IgA to OVA, and we still had protection. So at least in the mice, IgG are important. And in the human, I have preliminary data, but I cannot show you that today, next time. So TGF, IgG, and then vitamin A. So if you expose a mother to OVA during the whole lactation, it induces protection. But if you expose the mother to the egg antigen only the first week of life, you do not induce protection. And we wonder why. And why was related to the gut barrier. We compare the gut barrier in 1 week old mice versus 3 week old mice. The mice are a bit premature compared to the human, and so their gut is really not fully developed. And so you see that that's 3 week old, or it is a 1 week old mice that has been exposed to breast milk containing supplement of vitamin A. So you can accelerate the maturation of the gut epithelium and make it more tight and more developed with supplement of vitamin A to the lactating mother. So you influence the gut barrier. And you can also influence the capacity to activate T cells towards regulation induction by giving vitamin A. So here you have T cell activation that you measure in a 5-day-old mice receiving egg antigen through the milk. And you see that when they are 5-day-old, they do not respond very well. Unless they had received supplement of vitamin A through the breast milk, now T cells in a 1-week-old mice can already respond and be activated and mount tolerance. And this results in all adult mice. You check now their reactivity to egg. You challenge them with egg. The ones that were exposed during the first week of life, they are not protected from allergy. But if they were exposed to egg together with vitamin A in the first week of life, then they get protected. Is that also okay? It's more complex. Just showing that in early life, inducing oral tolerance doesn't work very well. Probably microbiota play a role. What we have highlighted is the role of vitamin A, and the neonate is physiologically vitamin A deficient. There is very low level in early life in vitamin A. You can accelerate aging in early life and give vitamin A supplement to the mother, and then you increase the barrier of the neonate, and you increase the capacity of the neonate to handle antigen and induce a regulatory immune response. So from this experiment, you see that's what's happening, and a briefly schematic way of what we found in the mice, most of the experiment, a few in the human. So if you expose a neonate to ovalbumin versus no ovalbumin, you will not change much. But now if you expose the neonate to ovalbumin and milk cofactor, and what we have been looking at, it's TGF-beta, you decrease the risk of allergic disease later on. If you expose to ova and vitamin A, to ova only during the very first day, nothing happened. Unless you add vitamin A, you can induce tolerance from the very beginning of life. And then if you have IgG specific to ovalbumin together with ovalbumin, you have immune complex, and you can also induce immune tolerance that is very profound. So you see here, just by changing the amount of a few factors, you can totally change the outcome and the susceptibility to allergic disease. So if I would answer to a question, is a mother eating an egg, will it prevent allergic disease? Well, the answer is it depends. And you see why. This is the answer that people don't like. They would like a black and white, but no, that's how it is. And to finish, I will talk to you about the naughty allergen, that is DERP1, that is the allergen from house dust mite. You remember we find it in the breast milk in similar amount as egg antigen. So we would expect, and we thought it would induce tolerance having DERP1 allergen from house dust mite in the milk, and it would induce tolerance, but no. Our experiment in the mice showed that if a mice is breastfed by a mother without having any house dust mite in the milk versus having house dust mite allergen in the milk, well, then you increase the allergy risk when the mice is adult. So you look at mice that are 6-8 weeks old, and you find they are more susceptible to allergic response to house dust mite. That is in the mice, and that's also true in the human, where it's not causal. It's an association we find again. When you compare the respiratory allergy risk in 5-year-old children during the first 5 years, children that had been exposed to milk containing house dust mite allergen versus exposed to milk that do not contain any house dust mite allergen, then you see that you really increase the risk once they had been exposed to house dust mite allergen. So yeah, oral exposure to an antigen doesn't mean you induce tolerance, even if breast milk is there. And probably that's good for infectious disease prevention. So now, indeed, when you see that, this is certainly not good. Before moving on, this is not good, and we need to understand why. We need to know what we can do, and that's what we are doing at the moment in mice. So we are trying to find what is happening, how is the immune system of the neonate activated by picogram of a house dust mite. And as Yervi was mentioning, you have intact protein in breast milk. And surprisingly, you have protease from house dust mite that can be found in the breast milk. So imagine the whole trajectory of all that. That's extremely hard to convince a reviewer that this is happening. But it is happening, so 2 years of review. Maybe it will get a review published one day, so I'm very happy to share. So the protease and in the breast milk, I can tell you, we have done 100 experiments to prove that. And this is disturbing the gut barrier. It's increasing the permeability, is activating the epithelial cells, liberating cytokine that is important for type 2 immunity development and favoring T helper 2 immunity and not protection. So can I also tell you that having house dust mite in breast milk will then also favor food allergy. Hopefully you will see that published. So that's about house dust mite. That's it's certainly not protecting, and we are working on how to decrease the level of house dust mite in breast milk, how to neutralize their protease activity to go in that direction. But then, let's go to this. When you have a tiny amount of an antigen that stimulates the immune response, well, this is vaccination. So can we extrapolate from that and say, okay, that's not good for allergy, but now imagine you have microbial antigen in breast milk, and Pierre Augra showed a long time ago when you vaccinate a mother with rubella vaccine, you find rubella, you find an immune response in the child also to rubella, thinking that something is happening. And what we think may be happening is that the antigen that are transferred in breast milk, even if the child is not infected, only the antigen could be in the best way to activate the immune system, be all the cofactors that are required to prime the immune system. So this is a study we want to do with Thomas Egwang in Uganda. With him, we have been looking at breast milk of an infected mother. We know about 10% of the mother have malaria antigen, 90% do not have. And we would like to know the outcome. Are the children that are exposed to malaria antigen, will they be protected? We need funding. So we'd like to do that. So we can conclude, and I think you all agree, we can conclude that breastfeeding has a clear impact on immune system function in early life and is critical to prevent infectious disease. And it will also influence the immune trajectory. Certainly in case of allergic disease, we have now accumulating data that according to the presence of allergen and cofactor, you can have more or less allergic disease susceptibility. And of course, all the research I'm doing with my team is to know what can we do to modulate this breast milk composition to decrease the risk in the long term for allergy. So this is the team. These are the super nice people that joined me in Western Australia, in Perth, the most isolated city in the world. But you see, I'm not isolated. I'm with Aquila. Aquila has been working with me for 10 years in France and did the big jump moving to Australia. Patricia did on a few years with me in France for her PhD, and then I succeed to get her and her family also coming with me. She had moved back to Brazil, but then joined the team. And I met Lieke in Japan. She was in New Zealand finishing a postdoc, and then she also joined the team. And we are male-friendly, so Jacob Byrne recently joined the team, and we're very happy having him working on also how to inhibit house dust mite protease activity. And here are the collaborators, in particular Susan Prescott, who gave me access to birth cohort, which is a huge amount of work which I skip thanks to people mounting birth cohort. And here's Thomas Egwang, a super motivated and enthusiastic researcher in Uganda, calling me up probably every day to know where I am, what am I doing. And I'm very happy we will have a student from him coming to Perth. And I'm also thankful to Larsen Rosenquist Foundation, and I forgot to mention at the beginning, that funded this famous chair I'm very fortunate to have. And I thank you for your attention.
Thank you very much. You covered a tremendous amount of information in a relatively short period of time. And there are a number of areas which I think we can bring questions up. Jerry?
A simple question. Ovalbumin in milk, how does it get there? You said immune complex IgG with whatever, but when you ovalbumin has a molecular mass, what, 45 kilodaltons, I think, somewhere there. In what molecular mass is it in milk? Is it still free of albumin, or is it complex to IgG, or is it complex to IgA? Because we do have antibodies to albumin and IgA. So what form is it, and does that make a difference in the outcome of the sensitization?
Yeah.
Because if it's IgA immune complex, perhaps it would not induce allergies.
Yeah, ovalbumin is not inducing allergy. It's inducing protection. And when you, it's
No, I realize.
Yeah, so I can comment later on for house dust mite. But for ovalbumin, we did Western blot analysis, and we found intact ovalbumin, and others have done that. And we did analyze if it was bound to IgG, and we find that when the mother are immunized in the mice, most of the ovalbumin is bound to IgG. Now in the human, we found ovalbumin and IgG and IgA, and we tried to measure immune complex. After a few years, I would say, I have stopped doing that because there is lots of cross-reactivity when we do immune complex analysis, and the Western blot was not sensitive enough to detect ovalbumin in the breast milk. So that's one thing. Now regarding the house dust mite, of course, if house dust mite allergen are bound to IgG or to IgA, it may change. In the mice model that I show you, we find that we use a model where the mother are exposed. There is IgG, there is IgA, and however, there is an increased risk of allergy. So that's the answer.
Well, that may not answer the question. I would take radioactively labeled ovalbumin, added it to the milk sample, and then put it in not Western blots or anything like that, because you'll dissociate the immune complex. Put it on some gel filtration material so that there is no dissociation of immune
we did
complexes.
that. Yeah.
Will it change the molecular mass? Will it be much bigger? That's the question.
Yeah, we did that. We did gel filtration. We measured how are the immune complex. It's big immune. Most of the immune complex are big immune complex. We tried to feed the neonate with those immune complex to see whether there are some immune complex that are protective or not. But it's absolutely not the same. When you do that, you don't have protection. Other things are missing, and it's not continuous breastfeeding. When you give.
No, but does it change the molecular mass? 45 kilodaltons, if it's in a complex with IgG, it will be 200, let's say.
No, I can't answer that. The amount are very low, so it's not that
matter.
easy.
If it's radioactively labeled, you don't care.
You talk about human, about mice. In the mice, I cannot get enough milk. And in the human, I haven't done it.
Okay.
Yeah.
Dr. Lips, is there a question there in the back?
Yeah. Why did you choose egg protein to induce immunotolerance here?
Okay.
Yeah. Why did you use egg protein to induce immunotolerance rather than cow's milk protein, an allergy to which is far more common in the first year of life, even in the breastfed infant?
Okay, so there are a few answers to that. So first, in Australia, for instance, in the birth cohort I showed you, the main allergy is egg allergy. So I think egg allergy is quite common. Two, we have done also analysis with cow milk, beta-lactoglobulin, and then we find that it's not that protecting as good as egg is. I don't know if it's that one, your question. So why we use ovalbumin? That's because I'm an immunologist, and you have many tools to look at response to ovalbumin. So when you want to modelize the question, it's easy to use ovalbumin. You have lots of tools. So that's why I use ovalbumin as a model for respiratory allergy initially. Then we move to the human, and I think egg allergy, you may have noticed in Perth cohort, there are 14% of children that are allergic at 1 year in a high-risk cohort, and among them, they were nearly all egg allergic. So that is really very common. It's true now, of course, we need to extend our observation to cow milk, and that's on the way, looking at correlation between beta-lactoglobulin and cow milk allergy.
There's a question up in the back.
Hi, Valerie. Sergei Ukrains of Moscow, Russia. Thank you for your wonderful presentation. It's always a big pleasure listening to you. I've got this question. It's a practical question. It's not that black and white, but still. Would prenatal exposure to eggs in pregnant women would change something in the events after birth? And then talking about eggs, how many per day? Or how many eggs would be too much? And stop being protective.
Yeah. Debbie Palmer she's in Perth also, and she's really trying to answer your question. There are already answers. So she published the Quest study, where it was an intervention trial. Mothers were receiving 0 egg a week versus 1 or 2, 3 or 4, or more than 5. In Australia, they love eggs. I think they eat every day 2 eggs. So they eat a lot of eggs. So they analyze then in those different groups the presence. So they tend to be a dose relation. The more egg, the more chance you have to detect. But however, the group eating 5 eggs a week, there was still mother that had no egg, and it's a high proportion. It's about 1/3. And on the opposite, the one that avoid egg. So it was a randomized controlled trial. They had strict instruction. This is slightly strong. When you have 0 egg, 2/3 of the mother had egg detected in their breast milk. So when we talk about avoidance, you don't know where does it come from, but they are. Now about pregnancy, again, Debbie Palmer is doing a clinical trial called PregNut. She's exposing or not mother to egg and nuts during pregnancy and lactation, and we'll see the outcome, but it will take a few years.
Thank you.
I'm going there because this...
Frank Rommel from Paris.
Yeah.
Hello.
Yeah.
Thank you for this wonderful talk. Really very stimulating. You highlighted some experiments in animals with vitamin A, showing that you increase the tolerogenic effect, which is well known, that is shifting immune responses depending on vitamin A concentrations towards Treg priming. Do you have human data on this wonderful hypothesis that perhaps vitamin A supplementation might be key to induce or increase tolerogenic reactions? And the second point I wanted to ask you, but perhaps it's overlapping with the next topic about allergy prevention. Our allergologist told us and teach us, you sensitize yourself during the skin, and it's depending on the filagreen mutation. So if you mutate it or not, you do not have the same risk. Probably, do you want to comment on this second observation, since you induce oral tolerance via the GI tract?
Yeah, exactly. Thank you. So the first question was about vitamin A. Surprisingly, we found that giving vitamin A to lactating mother was not stimulating FOXP3 Tregs, but Th1 cells. So that's one thing. It's interferon gamma dependent protection. And in the human, I found 2 studies. So there is one that look at an association between level of vitamin A in early life in children and asthma risk, and they find an association that goes in the same direction that we see. The one that had very low vitamin A level in early life, they were at more risk. That's an association. But there is an intervention trial in Guinea-Bissau, I think, where they gave vitamin A, but that's in Guinea-Bissau, to children, and they found that when giving vitamin A in the first day of life, you had an increased risk of allergy. So for me, the explanation, because you always find an explanation you like, but the explanation I like is that in Guinea-Bissau, enteric infections are endemic. So then you're giving vitamin A and an inflamed mucosa. And vitamin A, I think, is just, as the literature is suggesting, promoting is an excellent adjuvant. So if you have ongoing Th1, T helper 17, you give vitamin A, you will increase that. So I think there is still I think it's possible that vitamin A could help, but no one is testing that.
You had a question, Joe?
Yeah, Joe Newton from Florida. Your comment about the IL-33 is really interesting. Mm-hmm. Is this something that you see in premature babies? Is this something that may persist? I'm sorry. Your comment about IL-33 is fascinating. So my question is this something you might see in premature babies, or is this something that might even persist in babies who are premature? And the reason I ask that question is one of my colleagues, who's a pediatric dermatologist, has done an epidemiologic study where she has seen less atopic dermatitis in children who have been in a neonatal intensive care unit compared to normally born term babies.
Okay, so you like the data on IL-33 because it's related to development, or because we find the effect on house dust mite?
It comes from the lungs.
Okay.
Yeah.
Okay. It is something that is stimulated by. It is something that is stimulated by lung development.
Yeah, exactly.
And our premature babies, many of them have poorly developed lungs.
Exactly. Yeah.
And so the question then arises: is it possible that this IL-33 low IL-33 is something that is present in our premature babies? Is it something that persists?
Yeah.
And if it is important for stimulating some of these allergic responses, is that why this particular observation that my colleague has seen?
I'm wondering exactly the same question. I would like to know how is IL-33 producing.
It's an interesting association.
Yeah, it is indeed. And now I realize I did not answer to the second part of question regarding permeability. I don't remember the name of the French person there.
But as part of that question.
Yeah, you asked me something about the permeability.
Yeah, the filaggrin mutation.
Yeah, the filaggrin. Yeah, so everyone thinks that sensitization occurs through the skin. I think sensitization can certainly occur through the gut. And certainly in early life when the gut barrier is not developed, and when you have insult like house dust mite or the molecule that alter the barrier.
I like that comment because my field of reference is IBD, and if you look on leaky gut and altered barrier, it can also be in the neonate. So the skin only hypothesis it reducing it too much. Yeah. Thank you.
As part of that question, Joe asked, do you think either the cutaneous microbiome or the gut microbiome may have impact on IL-33 generation, particularly in the context of atopic dermatitis? If you keep these kids, their microbiome in the skin may be quite different than the normal children.
Yeah, I'm sure there must be data on that. I'm not aware, but there is lots of research now on IL-33 in the context of IBD, for instance, and I'm sure people have looked at microbiota, but I don't know.
I would like to ask how your very nice results relate to timing for introducing solid food. If you recommend to do it early together with breastfeeding or later, mainly, of course, allergens, not only all antigens.
Well, yeah, if you look at the amount of antigen allergen you have in breast milk, it's very low. And if you look at those data that have been generated in the mice, certainly is that the neonate is really more happy to respond to low amount and to mount the correct response with low amount. So to me, breast milk is ideal to prevent allergic disease because you have a diverse amount of allergens. You have everything. All what the mother is eating is there or not there, depending on the mother. But you have much chance to have a panel of allergen. While now we are proposing to those babies that are 3-4 months to eat nuts, to eat kiwi, to eat so many things, I don't have the feeling this is really adapted to that period of life. However, breastfeeding is not protecting from allergy. So you have those allergens, but it's not enough. So maybe the breast milk composition has changed. It used to protect, but the maternal diet has changed, doesn't have maybe enough fiber, maybe doesn't have the good microbiota, and the breast milk now is lacking the cofactor. That's possible. So let's try to keep all those allergens in low amount plus what is needed, and let's find what is required to get the good milk composition.
That was an excellent presentation.
Thank you.
I would like to take issue, not really an issue, maybe on semantics of 2 statements you made. One was on the neonatal immune response has no memory.
Yeah.
And that I'm not sure.
You're right.
I would accept. Okay.
And there is a paper also showing now that in the fetus now you have memory cell in the gut.
Yes, I think that maybe need to be requalified in the context of
low memory, let's say, compared to the other.
It may be lack of prior exposure more important. Mm-hmm. And the second issue was, you said the neonates is biased towards allergy.
Towards the
which
type
is
2
again, I think I would like to qualify that in the context of, is it a predetermined atopic child or non-atopic child? Because the bias may be driven by prior exposure to the antigen or lack of prior exposure to the antigen in the mother or the child. So I'm not sure babies are by nature biased towards allergy.
Yeah, I think they're biased to no tolerance. They're biased, it's hard.
But that's not the same thing as allergy.
No, it's hard to have oral tolerance, and they're biased, I think, to allergy because of the growth. And the growth and the repair mechanism are associated with production of molecules that's important for allergy. It's like this IL-33. And we know more and more that type 2 immunity is an immunity that is involved in growth. Right. So it's by default something that is physiological.
But the default is, I'll tell you, because there are some data on ovalbumin, with which you have worked quite a lot. We worked with it, and with Dick Rothberg, one of my old colleagues, we worked with ovalbumin and viral infections. Mm-hmm. If you have uptake of ovalbumin in the context of viral infection like respiratory syncytial virus in terms of asthma, if you have infection, you dramatically increase ovalbumin uptake because of the infection. So the cofactors may be more important rather than any underlying bias for the process itself.
For sure. That's why there is lots of hope.
Any other comments?
Thank you.
Wonderful talk. Thank you so much.